Hi. So in this video what we're going to look at is the intersection of a line with a plane. Okay, so firstly we need to consider how they interact with each other. So I've tried to sketch that on the left. We've got the plane represented by pi and the line represented by L. So the two things we're going to be asked with this is how to find the point of intersection with a line and a plane, and how to calculate the angle the line makes with the plane. There's nothing really within this that's fundamentally difficult. It's just a lot of remembering what to actually do, as it's just a bit of substitution or a little bit of higher maths. So we consider the plane, and remember that part of the plane is the normal to it. So I'm going to draw that one. So it might be a bit difficult to see, but the blue line is the normal vector to the plane. And what we're trying to find is theta, the angle that the line makes with the plane. So what we could actually just do is find the angle that the normal makes with the line and take it away from 90, because we know it's got to be less than 90. So what we could then do is adapt our formula of how to calculate the angle between two vectors so that it applies for this, where we're just going to have to find that angle and then take it away from 90. So there, what I've done is I've used the letter A to represent a vector through the line. And then what else we can actually do is that, knowing by our laws of trigonometry, cos 90 minus an angle is actually just sine of the angle. And the reason I've done the modulus bars is because we know it must be less than 90. If we were to get a negative answer there, we would end up with a value greater than 90, which we know it can't be. So it's really just an adaptation of the formula go there and higher. And as long as you can remember how to interpret the line equation and the plane equation, you will be fine. So if we look up here, first thing I need to do is find the point of intersection, which is just rearranging of algebra, and then we'll go into part B. Okay? So for the line x minus 7 over 3 equals y minus 11 over 4 equals z minus 24 over 13. For the plane, 6x plus 4y minus 5z equals 28. Find the point of intersection. So the first thing I'm going to do is I'm going to convert the line into the parametric form, and that's going to allow me to substitute that in to the plane equation and allow me to find the parameter at which those two intersect. I'll talk through that. So first thing I did, I converted the line equation into the parametric form from the symmetric form, giving me x equals 3 lambda plus 7, y equals 4 lambda plus 11, and z equals 13 lambda plus 24. I then substituted each of those equations into the plane equation, giving me the huge long equation on the right. I then solved that for lambda, the parameter, came out as -2, and that allowed me to substitute into the line equation what lambda is, giving me the coordinate when lambda is -2, which is where those 2 points, the line and the plane, intersect. So really it's just a little bit of rearranging and being able to interpret the graph, okay? The equation. Next thing I need to do is calculate the angle the line makes with the plane. So the first thing I'm going to have to do is get the normal to the plane, the vector through the line and the normal to the plane, and calculate the angle between them using sine theta equals the modulus of the formula we learned in higher. So there, part B. First thing I did was I read off the normal equation to the plane, which remember is just the coefficient of the x, y, and z. So I got 6i plus 4j minus 5k. I then read off the vector going through the line, which is the denominator of the symmetric form. So I've got 3i plus 4j plus 13k coming from then I just found the scalar product. So 6 times 3 plus 4 times 4 plus -5 times 13, which I actually kind of did in the first section anyway. And then I found the magnitudes of them, and I just substituted them to the formula, giving me 14.7. Yes, it's negative, but it's modulus, so that would just be, so when I put it into the calculator, I just ignored the -31 and just made it +31 because it's the modulus. And then I got that answer, 14.7. So that is the intersection of a line with a plane.